Hi everyone, welcome. I'm Michelle Vo, and I'll be your host for today's Let's Learn session. As a program manager dedicated to educational initiatives within the START community, I'm thrilled to explore the new Meta Quest Runtime Optimizer with you all today. Our Let's Learn sessions are here to help share new products, updates, and lessons to help your development journey. And today, we're really excited to give you a sneak peek at our new Runtime Optimizer. Today we have our speakers Nico, Lopez, and Hsia here to talk about the Meta Quest Runtime Optimizer. We'll cover a quick introduction to a new tool coming out soon this month, and a few helpful tips on streamlining your development process, performing a bottleneck analysis, performing a what-if analysis, and more. Performance optimization is a hot topic this month, so if you're interested in learning more, be sure to also tune into our Build Along session on Friday at 11 a.m. Pacific Daylight Time with our mentor, Sydney. Learn more tips on performance optimization in real time. And now I'll kick it off to Nico and Jay.
Thank you, Michelle. Hello, everyone. I'm Nico. Over there's my partner, Jay. We've been working on this cool new tool called the Quest Runtime Optimizer. A little bit of the motivation behind this tool is that we've been receiving a lot of feedback from users regarding, the performance optimization process being a little bit nebulous, difficult, requiring a high degree of expertise for a lot of users. And the Runtime Optimizer tries to address that issue by focusing on a tool that hopefully gives you actionable insights to what's going on during the runtime of your application. It is focused for non-GPU experts, which we consider to be the first line of defense. Whenever there's new assets being added to your game or whatever, hopefully this empowers technical artists as artists and anyone involved in the pipeline to take action on the performance of your game. That doesn't mean that this isn't also a potentially very useful tool also for the people that are already technical experts and profiling experts that might be using already advanced tools. Part of the motivation of bringing Runtime Optimizer into Unity was to increase and speed up the developer iteration loop. So there are great tools like Perfetto, RenderDoc that we support, but normally they require, first of all, a high degree of expertise, and also require you to leave the Unity engine, which, as we've noted through UXR sessions and whatnot, we've heard from you that we want tools that are inside of the engine and not leaving Unity is important. After that, the emphasis of this tool is also to focus on actionability. What happens, what can you do after you diagnose a problem? We're focused on bringing insights to any capture that you make and help guide your debugging and optimization journey. That is the emphasis of the Quest Runtime Optimizer. I'll go through a little bit of what the tool is going to be offering and how to set it up and use it, and then we'll open up some time for some Q&A. So the idea of the Runtime Optimizer is that it's simple. It offers two modalities. One of them is called the bottleneck analysis. You will see it in the button to the left. And there's another part of it called the game object timings, or the time save analysis part of the tool. So the bottleneck analysis tries to answer these two questions. First of all, how is my game bound? If you're missing frames, if your frame rate is struggling, what is the bottleneck that you're facing? Is it GPU bound? Is it CPU bound? If it's GPU bound, what is contributing to that GPU boundness? Unity as a whole offers a great suite, CPU tools to really dive into your CPU performance and figure out how your game is GPU bound and whatnot. But there is a little bit of an opaque part of things, which is the GPU side of the Quest's performance. That developers, if you're not using RenderDoc or one of these more advanced tools, you have no insight into what is going on there. So we try to surface that information through the bottleneck analysis. And in addition to answering the question of how my game is GPU bound, we're also answering what are the possible inputs that contribute to for my game being bound. The idea here is that we want to use the language that you're used to in Unity, like game objects, like the words game objects, materials, and vertices, meshes, and actually add the references to those materials so you can clearly see, okay, these textures that I'm using are highly uncompressed and are contributing to the GPU boundness of my game, right? So we want to use the Unity language inside of the tool, hopefully also making it easier and more accessible for all of you developers. Great. And then the second part is the time save analysis. And the time save analysis is just answering one simple question: which game objects are the most underperformant in my scene? So we're in the same vein. We're talking about game objects, a unit that is very familiar for Unity developers, and we're trying to give you the exact cost, the exact GPU cost that a game object will be incurring in your game. So you'll see the exact GPU time of, like, if you added a tree, how much does that contribute to your frame time? If your frame time is 11 milliseconds, how much of that, and you have a GPU time of 8 milliseconds, how much of those 8 milliseconds are the new tree that I added? You will be able to answer the question with the time save analysis. So those are the tools and two modalities of running this analysis that we're offering with the Runtime Optimizer. Next up, we have an example of what are the insights that we are going to be capturing. If you look to the left, you'll see a little bit of a thumbnail, right? A screenshot of what was being rendered by your compositor, right? What was being rendered at the moment. And all of these tools are runtime tools, but they freeze your headset, right? They freeze your frame, and they try to freeze everything in your operating system to make sure that we have the most reproducible results possible and the most stable results possible. So we'll take a capture of what we're seeing in your frame at the moment of capture whenever you clicked on capture frame under bottleneck analysis, tell you what was the FPS at that given moment, and the thumbnail will give you a little bit of a preview of, okay, you're GPU bound or you're CPU bound, and the GPU time that you're taking is 14 milliseconds. Great, and then afterwards, you can, whenever you click on one of these thumbnails, you can take several captures, right? You can resume the game, capture another one as you play along. Whenever you detect that, your frame rate is low, and you'll click on one of these thumbnails, open up the analysis window to the right that shows you the insights. First, it will show you the insights of, okay, your draw call count is high. Here are a few suggestions that you might have and links to documentation. Your Vertex process cost is high, and hopefully clear explanations that link you to documentation. This is a little bit maybe complicated, but this is just for reference for everybody here. These are the parts of the pipeline that we will detect boundness for in terms of what insights we're giving you. So like if you're texture bound, if you're meaning that, hey, you have a certain bandwidth and available throughput here, and if you're reaching the limits of it, we'll flag that. And these are the formulas based on, best practices that we've acquired and talked with all of our, first party studios and developer relations people. So we're looking at texture boundness, fragment boundness, vertex boundness, draw call boundness, and vertex fetch boundness. These are the main areas of the GPU render pipeline that we think you'll be able to action upon, and we'll warn you about these potential bottlenecks that we might be finding in your game. Over here, we'll see the material. This is part of the render resource breakdown that we will also show in the bottleneck analysis, which will show you what inputs for whatever you're rendering in your frame are contributing, and what degree they're contributing to your absolute frame cost. In this case, we are looking at material info. You'll have information about what materials you're using, and as I mentioned before, we're still using the Unity language, right? We're giving you links that you'll be able to Control F or click on and open in your scene viewer and look inside of Unity and zoom in through your scene. Whenever you find one of these materials, you can reference it in your directory. You'll have a bunch of information about, pixel shading cost, vertex shading cost. If you're interested in material information, texture information, you'll have information of how much memory this is using, and there's different modalities that this information can be presented to you. If you're not interested in actual megabyte numbers, you can look at percentage costs and whatnot. There's also vertex information, and we're linking you to game objects. And yeah, so these are the inputs that contribute to your final rendering cost. And we'll be showing you and ranking them hierarchically, hopefully with the aim to guide your debugging session, your optimization profiling, your profiling, and guide your prioritization through the process. These are the costs that we're going to be showing you. Previously, in the previous image, I showed what these windows look like, the material and shader costs, the geometry costs or vertex cost, and the texture costs. And these are the formulas that we're using to calculate and organize them hierarchically. So yeah, hopefully this highlights which of these materials, vertices, game objects, textures are contributing the most and contributing to expensive rendering inputs. And the last modality that we support in the Runtime Optimizer, which is ordering game objects by their cost. And I think this is a very powerful part of the tool, something that isn't available, this data isn't available anywhere else unless you're potentially using RenderDoc, which is a little bit more of an expert level tool, but now it's available on Unity. The idea is here that whenever you click on Scan Game Objects in the highlighted red square, we'll run an experiment in the background. And this is just a little bit of context for you, if you're running this tool. We'll run an experiment in the background where we freeze all the resources of your operating system, we freeze your frame, and we run an A/B test. Where we disable all the game objects in your scene one by one and calculate the cost of the game object compared to a baseline cost. And that's how we derive the total GPU cost or CPU cost of a game object. Here, if we look to the bottom right, we can see that there's you can see the game object names and their cost in milliseconds. And the idea here is, we're profiling one of these, Unity template scenes, and the first game object actually it belongs to one of the trees that we recently added that is very expensive and has very expensive vertex shaders. So we can see that the GPU cost is 4 milliseconds. If your total GPU cost is 18 milliseconds, that is a big chunk of it that is being consumed by this tree that we added, for example. So the idea here is that having the breakdown of game objects ordered by cost will help you prioritize what game objects, if I'm a technical artist, what game object should I focus on making, reducing the number of vertices in, or simplifying the shaders or materials that I'm using. That prioritization can be helped by using this game object timing tool. It's a quick experiment that you'll click on it. It'll run for, 20 seconds. In the background, you'll see things pop in and out, and we'll get this final result of the analysis. Great. So yeah, normally this is called, the holy grail of, rendering, attributing what the game object cost is per game object, the GPU cost per game object is. That is very helpful in your debugging sessions, and hopefully you find it useful too. This is a video, just a little bit of an illustration so you can see quickly what it looks like to run this scan game objects button in module. The idea here is that you'll see game objects popping in and out of the scene, and that's how we run the experiment in the background and give you the total GPU time. So we worked with Qualcomm to get these very accurate GPU timing metrics and surface them in Unity. So yeah, a little bit of a helpful thing next up is how to use it. This is just a quick video of what the process. Maybe Jay can describe it if you can see it.
Yeah, I can. So
Okay.
this is the So this is the interface that we created so easy to use. So first, when you just install a tool, the runtime optimizer enable will probably not be clicked. So click that will set up some stuff in the script itself. The next step, open build settings. You're just gonna open up your normal build settings, how you're gonna build the project. For this tool, for now, we do require development build. So build target in development build, install your APK as normal. Once after installation, you can right-click the launch button. The executable path will actually try to figure it out by itself. So hopefully when you click on it, it will just fill it for you. And when you launch, it will try to connect to the headset. So what happens is that we'll have some sort of server connection that try to establish. As established, you will see the connected being green. And then at this point, you're ready to capture. So here, I think it's showing that, once you verify it's connected, you can go ahead and click on the capture frame. It will freeze the frame as you see your scenes kind of like stopped. And then it will, in the background, it will do some captures and it will do a process to get the data out for you. So this is the end of video.
I think maybe we can skip it a little bit. I don't know if I am.
Oh,
Oh,
yeah.
there we go.
Yeah, it's in real time actually. So it takes a little bit, like 20 seconds or so to when the capture is done, and it will very quickly give you highlights of are you GPU bound or CPU bound? What's your FPS? So here is shows you that. So once you click on it, click on the picture, it will show you basically the analysis, what's going on there as in previous slides that I already told you. So you can scroll down, it probably will scroll down in a moment, and it will show you all each categories where its boundness. So it has a sort of like a highlight, your draw call in SAA level, triangle counts, and what texture are loaded at the moment. So again, those numbers are, sort of like we survey our first party developers and such, like, when they create those titles, what's their rule of thumb, and we take those numbers there. Here is like we just sort, all your geometries by the geometry count, and there's like the textures by their memory, and material sorted by their material is actually not sorted, but we just show the material and their uh, construction counts and such. So
I think
here
we
I
can,
think it's trying to,
yeah, we can fast forward it a little bit. I think it
oh, and
might take.
now I think we're trying to do the scene scanning, which is essentially sort of like almost like a A/B test. Here it's trying to show you it's blinking through objects, so that's where the experiment's being formed to see what's the cause of each game object rendered in the scene. Um, yeah, it's gonna take a little bit, depends on how many objects you have in the scene. But all this process again, your has frozen. Also, once it's finished, you can see the things unfroze, and you can see the LOD 0. It's the most expensive thing. It is actually the tree. Um, yeah. So here it brings you the outliner of your scene, and you click on it, it will brings you to the LOD level 0 of the cherry tree. And if you've seen the scene before, you probably knew that there's actually quite expensive, and there actually Vertex animation applied to on the tree. So it's not only a lot of geometry, it's also moving. So that with this tool, hopefully, that's what we're trying to show you, that very quickly by doing a scanning of the scene, you can find out what's most expensive. And then here, if you have outline or you have the scene present, you can just go in there and modify or simplify the asset right there. Then, once you build, you can do this loop again to see how much it has improved by using the tool.
So lastly, this is just a little bit of TLDR of like when you should potentially use the Quest Runtime Optimizer Optimizer. Some of the flows that we've experienced and used Runtime Optimizer and found it useful for is, whenever you have a high stable frame rate, a low frame rate for a long period of time, you can use something like OVR metrics tool or perf analyzer to understand where your FPS is, and if you detect that your FPS is very low for a while, then we'd recommend using the Quest Runtime Optimizer there. There are also, as I mentioned, Unity tools that are very good for CPU debugging, but they tend to lack and not have much insight into what's happening under the hood for the GPU. So if you detect that, hey, I'm GPU bound and I want to take a step further and understand why I'm GPU bound, of why am I texture bound, am I vertex bound, what is happening under the hood there, you should use the Runtime Optimizer. Unity 6 provides some of this info of high level view of potentially hey, you're GPU bound or CPU bound, but that's the extent of it. So if you want to take that step further, or if you don't even know if you're CPU or GPU bound in any version that is Unity 6 or lower, we recommend using the Runtime Optimizer. Yeah, if you observe that the scene is missing frames because of GPU work, you can use this. And if you want to push your graphics to the next level, so you're looking for what, maybe I am hitting my frame rate, maybe I am there, but is there anything I can optimize to push things and add more detailed meshes, better materials, whatever, and what can I optimize of my existing scene? If you want to push things further, tools like the game object timing, what if analysis are going to be very useful to help guide your prioritization in this realm. So yeah, hopefully that was helpful as an overview of the Quest Runtime Optimizer. So the tool is going to be coming very soon. It should be coming very soon. We'll be making sure to tell everyone in the START program first that whenever this is out, and hopefully you guys find it useful. But thank you so much for your time and attention. I'd love to hear any questions that anyone might have, and I'm happy to answer. Jay and I will do our best to answer them.
Thanks so much, Jay and Nico. That was a really great sneak peek as to what's to come this, I think, soon, right? I want to say potentially this month, but we'll stick with soon. But I think we got a few questions from the chat, and so I'll just go ahead and go straight into Q&A if that's okay. Sweet. So let me get right into it. So one person wrote, could this be used as part of a build pipeline to check for performance regressions, or are there already better tools for that anyway?
I'd love to hear a little bit more about, what build pipeline, what that refers to exactly, if this is some sort of automated, CI that people are using. Maybe if that is the case, there are some better, more SDK, CI friendly tools that you could use to look at performance and with maybe better interfaces. A lot of the focus that we put in here is on the GUI part of the graphics part and making sure that we have good linking inside of the Unity engine and whatnot. But if you're just looking at, is my game bound, CPU bound or GPU bound, you could use, Perfetto or something like that in the background that has maybe nicer interfaces and more simple interfaces to detect these bottlenecks if you're using it as part of CI. But yeah, maybe it depends on the exact build pipeline that we're talking about.
Yeah, if the person wants to follow up in the chat, feel free to add some more context if this helped answer your question about performance regressions and identifying them. So another person wrote, are there ways this tool can help us with CPU-bound apps with heavy non-Unity processes?
Jay, do you want to take this one, or I'll take it?
Did it mention CPU bound?
Yes. So are there ways this tool can help us with CPU-bound apps with heavy non-Unity processes? So I guess the question is around whether it's applicable to non-Unity processes.
Yeah, not yet, but I will encourage give us more detail. We chose GPU at the moment because we think the tool is lacking the most. But if it's Unity process, we might be able to help, but yeah, we'll say give us more details and we will look into it. But we can possibly incorporate that into the tool.
We got another question here in the chat. Any chance there could be a library to implement in my custom engine and having this as a standalone tool?
Yeah, it's a good question. We can look into that. It's just based on the interest, and we could, if there's enough interest for us, we could sort of like provide sort of like an SDK kit. Essentially, we are communicating with a lot of available tools on the headset itself already. So I would say it is possible. But then, currently we don't expose them easily enough at all to
That's
integrate.
Yeah, I would agree that it's like it is possible. You can hack things around, and we do give you. There is an interface that we are accessing through C# to access this like low level, render stage trace data, draw, very low level Adreno, GPU data that we are surfacing through Unity pipelines, but the interface isn't designed for this. I've heard of people being interested of like hacking something around it, but if this is a common use case, we'd be interested. We'd be happy to also clean up some of these interfaces, make it nicer so that this use case is potentially addressed.
We have another question in the chat. This person wrote, what are things I can do if my game is vertex fetch bound? I only have very simple meshes in my game, but lots of them rendered with instancing. Position data is split up and first in the vertex buffers, and I also experimented with different vertex data formats without any improvements.
Yeah, interesting. I would definitely suggest, try to use the tool. It will hopefully tell you, you're actually fetch bound or computation bound. Again, I would like to know, if you're instancing, are they animated or not? And I do hear that there's some issue with instancing in Unity as well, but I have to dig in for more information on that. Essentially, when you say you change vertex format, because that's not an easy thing to change in a lot of cases, where ultimately if you are truly vertex fetch bound, I would suggest looking to more extreme measure. There are different packing that you can do for precision. You can probably cut the precision down, but then you have to take gig track here in the vertex shader itself. And you mentioned you already split them. Splitting the data, as far as I in my experience, it helps in your shadow path because your shadow is gonna fetch position only, and then when your main render path is gonna fetch both. So if you split them, essentially, I think you are just speeding out your shadow paths because that's only the paths that gonna use only the vertex, but your main path is gonna still fetch everything, right? So there's those sort of things that you can consider. But again, I think you definitely try using our tool and see what kind of metrics you give it to you, or take a RenderDoc capture. RenderDoc is a more involved process. However, it will able to tell you even more detail if you're going to RenderDoc. Um, I would say it's a hard problem to solve. But yeah.
Thanks, Jay. I think the follow-up to that from the person who wrote in is the OVR GPU profile implies I'm vertex fetch bound. Also, it's all custom. Seems like they're working with a custom engine, so no Unity. So the tool doesn't help them in their case. They said also binning can also use positions only. So I'm not sure if that adds some more context, if you have anything else to recommend there.
Yeah, got it. Right, that's right. Binion's only position only. It does try to find the best. I mean, there's a little magic performed there to try to just fetch the position. Again, it's not perfect. So your vertex shader might still matters. I would say do a RenderDoc capture. If you're interested, you can share that RenderDoc here, or we can figure out what channel is the best channel. And then we can sort of, dig in the RenderDoc capture and see what's going on.
Yeah, and if folks are interested, maybe we can do a session covering RenderDoc. Just kind of curious if that is something people want to learn about. Definitely mention it in the chat if so. Um, would love to know.
This is a tool. Yeah, no, I think yeah, we do support the RenderDoc fork, and the goal of this, of the runtime optimizer is to hopefully bring a portion of the RenderDoc functionality into Unity and make it easier for all of you to debug and diagnose your problems. Yeah, and hopefully that's a big help for everyone.
Oh, and I see our moderator, Michelle, just dropped a tutorial that they made on RenderDoc. So looks like we have a lot of resources already. Okay, I'll jump into another question here. So someone wrote, can I influence what game objects are toggled in the experiment, since that is very specific to the actual scene and hierarchy?
Is there, I'd be curious to know if there's any particular motivation for that question, but the answer is, for now, no. For the experimental V1 version, you can't specify which ones. That is something that we want to, that is in our roadmap to enable, of like selecting individual game objects and just running the experiment on those. There is a consideration of, the time that it takes to run this experiment, right? You're toggling things on and off, running things for a few frames, and that might take 40 seconds, something like that. If you're iterating quickly, that might be a bottleneck. So yeah, we do want to enable that for users for sure. But I'd be curious what the motivation of just enabling a subset of game objects is, just to help our argument too, to prioritize this.
Yes, whoever wrote that, definitely put it in the chat so we know why you want to select specific game objects to study.
Yeah. And right now things are limited. Right now it's a little bit, we're looking at everything inside of your frustrum, right? Everything there is going to be part of this experiment.
On average, how long would you say the analysis takes? Maybe that's one motivation. Make it
Yeah,
faster.
it is. It's a time motivation for us of like why we want to do it. We've also heard some feedback from people that, hey, I'm an artist or something like that. I don't care about other parts of the scene, or I don't want to touch them. Maybe something will break. I think there's motivations there of just like isolating different parts of a scene and just running the experiment there.
That makes sense. Okay, and then our next question, this person wrote, is this intended as a substitute for RenderDoc? Are there situations where you'd want to use RenderDoc instead of the Meta Quest Runtime Optimizer?
Yeah, so that's a very good question. It's not substitute. The target audience is a little different. The workflow is also a little different. As you can see, this tool actually connects to your runtime. That means that you can actually play the game as normal to the certain point, to the point that you want to capture, or we actually have a mode that just kind of will do the capture in the background. But then after you capture, you can actually, resume the game. You can continue. RenderDoc, when you enable RenderDoc, depends on how heavy your game is, you actually incur a huge performance hit. So for some of the game, it's really hard or impossible to play normally with RenderDoc. So, and once you took a capture, you don't need to quit the app right away necessary, but I know that if you did several captures, you might have problem later on when you close the game that each capture will be preserved. So RenderDoc, I would say, is you know exactly where it is. Your game might have a mechanism to go there very quickly, do a capture, and then exit right away. And then your most workflow is with the RenderDoc, right? So the information you see, they're not going to correlate to your game object anymore. The shader you see, the texture, I don't even think has a name. But it does give you, more detailed information on each draw call and such. But this tool, again, we're sort of focusing on surfacing on the game object level. For example, for the tree, if you're looking to RenderDoc, it's probably gonna split the leaves and the trunk and some other parts by render differently because they might have different materials. But for us, we kind of accumulate the cost together, like, oh, that's the cost of the tree. So our assumption is that as an artist or tech art, they can go into, okay, I just gonna, reduce the furthest count of the tree, right? It's more, I guess, direct for in that case versus RenderDoc. You have to associate the draw call to the geometry. They have to go into Unity and look up what this corresponds to, and then modify it there. So our hope is just providing a direct way within Unity UI to allow actionable.
Thank you. Sounds good. So I guess from my understanding, you would want to use the runtime optimizer for things at runtime and things to look at game objects as a whole. But RenderDoc will, I guess, chunk things by like different materials and
Yeah,
sometimes might be too much information from what the intended user needs.
yeah, I think the one thing it's really hard to correlate back. For example, for RenderDoc, you probably don't know what material it is, right? You had to refer it back from the shader itself, perhaps, or the texture it used. But again, it's hard to say what, it sometimes it'd be really difficult to map that back to a material in Unity. Um, yeah.
So yeah, runtime optimizer, semantically matches Unity's, frameworks, but RenderDoc, might not, and it might be harder to map back, but has a bunch more detail, right? It has a lot more detail. You can go in at a pixel level into things and look into individual pixels, or you can look at, binning that is happening inside of, the runtime, and all that is very, complex and has a lot of depth. Here we're sacrificing a little bit of the depth to bring things into Unity, into the same language that we use in Unity, but hopefully providing a lot of value to people that are maybe at a higher stage in the funnel. Yeah.
Thanks both. Okay, another question we got in the chat. This person wrote, is there a command line interface for this tool? This is relevant to the build pipeline question that we asked way back.
There is not, but yeah, there there is not. We would love to hear your use case for it. There are command line tools that potentially could fit your needs. I saw someone mention the OVR GPU profiler, for example. Those that can give you some insights into what the GPU is doing, render stage tracing, draw cloud tracing, whatever it is. There are some command line tools there, but this processing that happens afterwards and all of the referencing Unity objects themselves, that is exclusive to the GUI that we have.
Thank you. And then another question someone wrote in is, I would love this in default Unity. Are you in contact or are you planning to contribute this potentially? This might be a little out of scope, but I feel like it's a nice
No,
one to
actually,
feel.
maybe we can't reveal too many details of our conversations, but yes, I think we do. Our aim is that we do want to bring this to the broadest audience possible. Something to note here is that this is a package that doesn't depend on the Meta Quest, the Meta Core SDK, which means that if you are, using just Unity packages exclusively OpenXR, you will still be able to use the runtime optimizer, which is big. Normally, a lot of our tools are bundled into this core SDK or other packages that depend on it. We are mainly interfacing with the operating system of your headset and talking to your headset directly. So it doesn't matter what you have installed as a package. So that's just something to note.
That's great to know. So anyone can use it, agnostic of whether they're using the Meta SDK or not.
Anyone building a Unity VR app will be able to use this.
Sweet. Okay, let's get on to our next question. So someone wrote, it would be great after the analysis to have options to be able to send changes across all objects, like the project setup tool does. For example, if we could change the compression value and format in all textures in use in the scene, is that something that could potentially be in the works to implement?
I think those are great suggestions, right? The holy grail would be that you have a performance issue, a bottleneck, and you can click a button and it's fixed, right? The problem sometimes is that things are very nuanced, right? You might make artistic trade-offs. You might, there might be certain preconditions that you might want to respect, and you don't there's not a single answer that we can apply for all any issue that you have. So, reducing the texture, reducing the texture sizes or things like that might not always be the answer for a bottleneck that you identify. So the answer is that's why, you know, some of these rules can't be applied to something like UPSD that you mentioned, the project setup tool, which is great. And I think I saw someone else mention that, you know, there are other tools, even third-party tools. I think there's like a Valum tool that someone mentioned. I think these are static analysis tools that look at, you know, the composition of your Unity project, which is great. You know, and we want to funnel as many of the best practices into these static analysis tools of, you know, yes, you should use dynamic res, you should use this type of compression algorithms, you should use all these things, and that's part of our static analysis. What happens afterwards of, like, you know, when you're in runtime and you see, you know, a particular angle, you know, we don't want to give you generic solutions for problems that might not require a generic solution. So you might want to, it's not like, hey, if you have more than 300 draw calls in all situations, you have to reduce the number of draw calls. You might be able to push that even further. So that, as a hard and fast rule, does not apply. But if you are in a scene where you are in a particular frame where you are draw call bound and we detect that based off of your metrics, then the recommendation makes sense. How we apply that recommendation is a little bit more, you know, it depends on the developer. We do want to take more steps into, like, if there are ways that we can make changes that are, you know, more actionable, we do want to take steps in that direction for sure. So maybe the texture change that you mentioned could be a good one. You know, like maybe that one could be a good you know, easy access way of, you know, changing the compression methods or whatever it is. We could enable that as an option for you to quickly, you know, identify what the insight is, what the potential bottleneck is, and help you action on it. But what we don't want to do is give you, like, the button to, like, automatically change everything to 3x3. I don't know. We don't want to give you that button. But if you want to, like, if we want to help you to action on the next step, I think that would be potentially valuable. So thank you for the feedback.
Thanks, Nico. That was really well detailed. And back to the question around Vellum's tool. That's a great question for Vellum, who is actually one of our mentors. So when the tool comes out, we can see if Quentin is interested in testing out the tool and maybe is able to do a demo or comparison. Um, so that's definitely potential. So just wanted to really quickly run through the last few questions that we have. Person writes, does the runtime optimizer have any telemetry to Meta in it? I guess when they're talking about specifically the cross-platform usage, just want to know if there's anything there.
Our telemetry data are only limited to the tool itself. So meaning that, you know, we do like to know, for example, where you might get stuck in the tool, you know, or what feature you guys are click on the most. But this basically limited to that. We don't collect any, you know, detailed information about your game or, you know, what other, you know, game settings, build setting. It's very limited, just, you know, the button click, or for example, when you produce analysis and things, there might be some errors. We try to collect those errors, but basically limited to the tools.
Great. And then I think one person wrote if there's any plans for Unreal. I'm not quite sure, but if you have anything to update, feel free to share.
Yeah, we will kind of try to look into it. I think this kind of like hand where if this tool receive really well, and we do believe there are true values for Unreal, we'll probably look into it. No promises right now, but that's on our radar.
That goes for, like, the whole experimental, you know, we have this flagged as experimental, you know, of, like, we want to hear all of your feedback and how everybody's using it, and does this provide value for people? And if it does, then yeah, well, I think absolutely, I think it's in everybody's best interest to, you know, expand this to other engines.
Thanks, Jay. Thanks, Nico. And I think that's where we're at in terms of time. I know, Yakov, you asked one question, which is, can this be used for regular Unity games as well? From my understanding, is it yes, or is it only for just VR games?
only Quest. We put data directly from Quest.
Oh,
Perhaps that.
not the data, the runtime optimizer. Can it be used for just flat 2D Pancake titles on Unity? I think is the question.
If it runs on the headset, it will work. Basically,
Okay,
we're getting data directly from the Quest headset.
gotcha. So
So
it has
running on that, yeah.
a Quest
Our
app. Okay,
source, yeah, our source of data is like one of this a Qualcomm library that is running in the operating system of the Quest. So if that's not there, it's not gonna work. Yeah.
okay. Thank you for clarifying that. So yes, you can use it on any app that's on the Quest, not necessarily a Meta SDK, but it just has to be on the Quest. Okay, folks, I think that is where we are at for today. Thank you so much, everyone, for tuning in. And thank you, Jay and Nico, for sharing your insights and this sneak preview on the Meta Quest Runtime Optimizer.